You know, it's funny. When you think about a camera flash, that super bright light, you probably think it's all about the battery, right? But the real secret is something else entirely. It's this tiny, unsung hero of the electronics world. And today, we're going to dive deep into this powerful little component, the capacitor.
I mean, really think about it for a second. You're in a dark room, you hit that button, and bam! For just a split second, this insane burst of light just floods everything. How in the world does a tiny little device pack that much punch that quickly? It almost feels impossible, doesn't it?
Well, the magic isn't just the battery. The battery has a partner, a little sidekick component that can slowly gather up energy and then release it all at once. It's kind of like capturing a lightning storm inside a tiny little can, just waiting for you to unleash it.
Okay, so to really get how this works, let's just forget about all the complicated circuits for a minute. Let's think about something way simpler. A bucket. But this isn't a bucket for water. Nope, it's a bucket for electrons.
So, what is a capacitor really? Officially, it's what they call a passive component. Now, all that means is that it can't create its own energy. It's not a power source. Instead, it's an absolute master at storing energy that you give it, holding onto it inside an invisible electric field.
And this is where that whole bucket analogy really starts to click. Just imagine the electrical charge is water. When you hook up a power source, you're basically filling the bucket that's charging the capacitor. Then, when you need that power for, say, the flash, you just tip the bucket all the way over and whoosh, all the water dumps out in one huge rush. That's discharging. And it makes sense, right? The bigger the bucket, the more water it can hold. And that simple idea brings us to a key concept, capacitance.
Capacitance is literally just the measure of how much water, or charge, that bucket can hold. That's it. A capacitor with a big capacitance, that's your 5-gallon bucket. A small one, it's more like a little coffee cup. And we measure this ability in a unit called the farad, which is named after the brilliant scientist Michael Faraday.
But here's a fun fact that gets a lot of people. 1 farad is a huge amount of capacitance. I mean, it's massive. It's so big that you'll pretty much never see a 1 farad capacitor in your everyday gadgets. Instead, engineers are working with these teeny tiny fractions, like microfarads, which is a millionth of a farad, and even picofarads. That's a trillionth of a farad. Crazy, right?
So, okay, we know what it does, but how is this little energy bucket actually put together? Honestly, you might be surprised at just how simple and elegant the design is.
At its core, a capacitor is basically a sandwich. Seriously, you've got 2 metal plates that can conduct electricity, and this is the most important part, they never, ever touch. There's a thin layer of an insulating material separating them, and that's called a dielectric. And depending on what that dielectric is made of, ceramic, plastic, whatever, that's what gives us all the different kinds of capacitors for different jobs. It's such a simple design, but it's totally ingenious.
All right, so how do we fill up this electron bucket? Well, when you connect it to a battery, it's just like turning on a faucet. The battery starts pulling electrons off of one plate, which makes that plate positive. At the same time, it's pushing the same number of electrons onto the other plate, making it negative. This whole imbalance creates this tension. It's an electric field right there in the middle, in that dielectric, and that's what holds the energy. And boom, just like that, your bucket is full. It's just sitting there, brimming with potential energy, waiting for the green light. And now for the magic trick. The moment you give all that stored energy a path to go somewhere, like, say, you connect it to the camera's flash bulb, those electrons just rush from the negative plate over to the positive one. It happens almost instantly. The bucket gets dumped, unleashing this sudden, powerful flood of energy, and that's what lights up the bulb in the blink of an eye. So cool.
Okay, so we've got the mechanics down. Let's take a look at the resume of this amazing little component. Because it's not just a one-trick pony for camera flashes, oh no. This thing has a ton of really important jobs in pretty much every piece of electronics we use.
Yeah, beyond that quick burst of power, capacitors are kind of like master traffic cops for electricity. They can completely block the steady, one-way street of direct current, that's DC, acting like a roadblock. But they'll let the chaotic, back-and-forth flow of alternating current, or AC, pass right on through. And it's this really unique ability that makes them perfect for things like filtering out annoying static from your car radio, or even smoothing out that lumpy voltage coming from a wall outlet, to give your delicate electronics a nice, clean power supply.
So what's the big takeaway here? It's that once you know what you're looking for, you start to see that capacitors are, well, they're like the invisible architects of our modern world. They are absolutely everywhere, just silently and reliably doing their jobs to make all of our technology actually work. I love this quote because it just nails it. Think of it this way. If a battery is a marathon runner, built for slow and steady endurance, then a capacitor is a world-class sprinter. It gives up that long-term stamina for just an incredible, instant burst of pure speed and power.
And look, if you need any more proof of just how important these things are, just think about this for a sec. The smartphone you might be holding in your hand right now, or the one in your pocket, has over 1,000 of these tiny components inside it. 1,000! And every single one is playing a crucial role, whether it's making your touchscreen work or cleaning up the signal for your Wi-Fi.
So yeah, the next time you see a sudden flash of light from a device, you'll know. You'll know about the tiny giant that's doing all the heavy lifting. It kind of makes you wonder, right? As our tech gets smaller and faster, what are the next generation of these little energy buckets going to be able to do? And what other invisible components are out there all around us, shaping our world in ways we haven't even thought of yet?